Oxidizing and reducing agent. When we look at this example over here, we have Mg and O2. This Mg becomes more positive because it lost the electrons, okay? It donated the electrons, so it's a little bit more positive. The oxygen over here received 2 electrons, so it's a little bit more negative, okay, as written here. Now, how did this start? Where did this Mg and O2 come from? It came from magnesium oxide, a decomposition reaction. So it decomposed into this. We're just going to quickly balance it out, 2 and a 2 over here. So this thing over here is technically this one over here. Now we're just going to be putting a 2 there because there was a 2 here, and we actually have to continue to balance this, so we got a 2 over here and a 2 over here, okay? Now, you're probably used to knowing that oxidation is just an interaction with oxygen, okay? This is what mostly people think, okay? But this is an outdated reasoning definition, because if we look at a similar example over here, look, the Mg is just interacting with chlorine, but guess what? There is also oxidation happening here, okay? So let's just backtrack a little bit. Where did this Mg and CO2 come from? It came from also at the decomposition of a Mg and CO2, okay? So Mg and CO2 is over here. It's already balanced. We're just going to be putting that over here. It's already balanced. Okay, actually, no, there's a 2 over here, so now it's balanced. Regardless, in both examples over here, Mg is being oxidized because oxidation has nothing to do with the interaction with just oxygen, but it has more to do with the transfer of electrons. So this Mg transferred electrons and it became Mg2+. This Mg here transferred electrons and became Mg2+. Now, an oxidation reagent is responsible for another atom or ion to lose electrons, whereas a reducing agent is responsible for another atom or ion to gain electrons. Let's have a look at an example over here. We have to identify those oxidizing and reducing agents, so we're just going to take this reaction, put it up here. I just created a net ionic equation, so I just split up the aqueous compounds over here so we can cancel out the like term spectator ions. I found this one here, I found this one here. They tend to be like terms, so I got rid of them. I brought down these ones over here, down here, that are left over. An increase in oxidation number is oxidation, okay? So where do we see an increase in oxidation number? Well, we have 0 over here. It became 3 over here, so this is obviously oxidation. A decrease in oxidation number is known as reduction, okay? So we went from 2 to 0 over here, hence why we've written out as reduction, okay? So Fe2+ is the oxidizing agent. Why? Because an oxidizing agent is responsible for another atom to lose electrons, okay? This lost electrons. What was responsible for this guy to lose electrons? It was the Fe, so he becomes the oxidizing agent, okay? And vice versa for the aluminum being the reducing agent, because iron 2+ was the one that was being reduced. Please try these 2 questions on your own, okay? So this here is the first one, and this here is the second question. Please try these on your own. I'll give you the answer shortly. This is the answer to the first question. This is the answer to the second question.